In this video, we discuss compile time initialization. So first of all, we see what is variable initialization. So this topic is already discussed in the previous video. Variable initialization means the process of assigning a value to a variable. It is called variable initialization. There are two types of variable initializations: implicit initialization or compile time initialization, explicit initialization or runtime initialization. So compile time initialization means that initialization process is done in the compilation process itself. So this is done using assignment operator equal to symbol, and explicit initialization means that is done during the runtime process. So it is done by using scanf function. In this video, we see compile time initialization. So compile time initialization means that process is done during the compilation process. So we see some examples. Now I am declaring a variable integer a. I am assigning some value. Let us say a is equal to 10. I am printing a value. A value is equal to %d a. Later I am assigning another value to a. A is equal to 20. Again printf a value is equal to %d a. So let us run this program. So we got output in the previous case. In the first case a value 10 and in the second case a value 20. So this is the output we got. So this is called as compile time initialization. Why? Because the variable is assigned with value 10 and 20 by using assignment operator, that is equal to symbol. So that means in the compilation process itself, we are giving value to a variable. In the first case we have given 10 and in the second case we have given 20. Now what happens here? We see with an example. Okay, let us say there is a variable a. So initially we have given value 10. So first of all we have got value a is equal to 10. Now what happens in the second case? A value is overwritten with value 20. Now there will be no more 10 in a. 20 is overwritten with value 20. So this is what happens in the second time initialization. So instead of 10, a now contains 20. So that means a value is overwritten with the second value 20. So this is how the initialization takes place. So this is called as compile time initialization, or it is also called as implicit initialization. So we see some other examples. Okay, let us say in this second example I am declaring multiple variables. Let us say a is equal to 10, b is equal to 20, c is equal to 30. That means I have declared three variables of type integer, and also I have assigned them with different values. Now I print those values, three values: %d a comma b comma c. So I run this program. Now I got value a value 10, b 20, c 20, c 30. That means, so I have declared multiple variables with different types of values with so I have initialized all these three different variables with three different values. Now we see second example. So in this example I will declare all the three variables of the same type, but I will assign them with a single value. A is equal to b is equal to c is equal to some 100. Now what I have done here, I have assigned multiple variables with a single value. That means I have initialized three variables with a single value. So I will run this program. We got a 100, b 100 and c 100. So this is another example. And now we see last example. So instead of having same data type, we see different data types. That is, I am declaring a variable of type integer, b of type float, c of type character, I will assign values also here. A is equal to 10, B is equal to 9.8 and C is equal to, let us say, plus symbol. What I have done here, I have declared 3 different variables and at the same time I have initialized all those 3 different variables with 3 different values. So after running this program, so we get this output. Sorry, we got error here. Sorry, incorrect value. Why? Because B is a floating type value, then we must use percentage F format specifier. So 10, 9.8 and sorry, for character we need to use percentage C. So we got output 10, 9.8 and plus. So in this fashion we can initialize variables with different values. So if the initialization process is done in the compilation itself, that type of initialization is called as compile time initialization and runtime initialization. But the problem with compile time initialization is, if we run this program 100 times, we get the same output, A value 10, B 9.8 and C plus. If we run this for multiple number of times, we get the same output. If we want to get a different output, then we need to change values of A, B and C. In order to change those values, each and every time we need to go to the program and then we need to change values in the program itself. So that means if I want to have A value different value, then I need to change A value in the program itself, and also I need to change B value in the program itself, etc. So likewise, in the compile time initialization, each and every time we need to change the values in the program itself. But in most of the cases, we want to give values to variables in the runtime itself. That means explicitly by the user. In such cases, we need to go for runtime initialization. So runtime initialization is done in the runtime process. So in order to use runtime initialization, we use scanf function. So in the next video, we see details about runtime initialization.